The James Webb Space Telescope has shown us what no human eye ever could. Worlds once thought silent are finally speaking. This isn't just science. It's the universe revealing its hidden truths. Pluto and Neptune are no longer quiet. They said space was silent. But James Webb proved that every star, every planet, has a story to tell. What if I told you the most powerful space telescope ever built just captured the clearest image of Pluto in human history, revealing secrets that have been buried in ice for billions of years? The James Webb Space Telescope, launched in 2021, was designed to peer into the ancient depths of the universe. But now, it's turned its gaze back toward our own solar system. And what it's revealing about Pluto and even Neptune has scientists completely rethinking what we know about the outer reaches of our cosmic neighborhood. Let's start with Pluto. Once hailed as the ninth planet, Pluto was officially reclassified as a dwarf planet in 2006. But that hasn't stopped the astronomical community or the public from being obsessed with this icy world. Back in 2015, NASA's New Horizons spacecraft flew past Pluto, giving us our first breathtaking look at its rugged surface, icy plains, and that now iconic nitrogen glacier shaped like a heart. But now, the James Webb Space Telescope has done what no spacecraft or observatory could before: see through the haze of Pluto's thin, frozen atmosphere using the power of infrared light. The result? The most detailed image of Pluto's surface ever captured. We're talking about an alien world marked by jagged methane ice mountains, ancient impact craters, and an enormous frozen heart stretching across the landscape, roughly the size of Texas and Oklahoma combined. Thanks to JWST's infrared capabilities, we can now see subtle differences in Pluto's surface composition, revealing patches of nitrogen ice, hints of a rocky core, and maybe even signs of a hidden ocean beneath its crust. But the surprises didn't stop there. Scientists analyzing Pluto's terrain believe this distant dwarf planet may have once flipped on its axis, literally. Imagine the entire planet shifting, rotating like a top that's lost balance. This phenomenon, called true polar wander, could explain why Pluto's massive heart-shaped glacier sits exactly where it does. That shift may have rearranged ancient landforms, creating the bladed terrain made entirely of methane ice. So sharp and jagged they look like frozen knives stabbing into space. And if that wasn't enough to keep planetary scientists awake at night, JWST then turned its eyes even farther, to the blue giant Neptune. And what it saw stunned even the most seasoned astronomers. For decades, Neptune has been shrouded in mystery, often portrayed as a glowing blue orb. Thanks to its methane-rich atmosphere, the planet has remained elusive since NASA's Voyager 2 flyby in 1989. But JWST's infrared imaging changed that forever. What looked like a simple blue gas giant in visible light has now been revealed as a swirling, ghostly sphere, filled with bright methane ice clouds streaking across its atmosphere and casting high-altitude shadows. And then came the rings. Yes, Neptune has rings. And for the first time in over 30 years, JWST captured them in crystal clarity. Faint, dusty, and often nearly invisible to other telescopes, Neptune's rings now shimmer clearly in Webb's images, circling the planet like ancient signatures of cosmic chaos. These rings, once only hinted at by Voyager 2, are now being studied in detail for the first time since their discovery. The deeper JWST looks, the more it reveals. And while it wasn't built to study individual planets, it's doing exactly that, uncovering a new frontier of frozen mysteries and rewriting what we thought we knew about the edge of our solar system. From Pluto's fractured heart to Neptune's haunting clouds and newly revealed rings, we're witnessing a renaissance in planetary science. So what's next? Scientists are now pointing JWST toward other icy bodies, dwarf planets, Kuiper belt objects, and moons that may harbor secrets hidden under miles of frozen crust. In a universe filled with exoplanets, quasars, and galaxies from the dawn of time, JWST is reminding us that some of the most astonishing discoveries are still waiting for us right here, in our own cosmic backyard. What if the secrets to our solar system's past, and maybe its future, aren't locked away in distant stars or exoplanets, but frozen beneath the surfaces of Pluto and Neptune? Thanks to the James Webb Space Telescope, we're now seeing these worlds in a way we never have before. And what it's revealing isn't just stunning. It's rewriting the rules of planetary science in real time. Let's talk about Neptune, the last planet in our solar system since Pluto's reclassification. It's 30 times farther from the Sun than Earth, and for decades, we've known it mostly through grainy photos and artist interpretations. But JWST just flipped the script. With its powerful infrared vision, it has pierced Neptune's methane-thick atmosphere, revealing not just storms and clouds, but a dynamic world full of motion, structure, and mystery. In visible light, Neptune has always appeared deep blue, thanks to the way methane reflects light. But in infrared, it's a whole different planet, ghostly pale, swirling with bright streaks and blotches. What you're seeing are methane ice clouds, shining like celestial beacons in the upper atmosphere. These clouds form at extreme altitudes, where temperatures are so low that methane gas condenses into crystals. And with JWST's sensitivity, we're able to track their movement, revealing wind patterns and seasonal shifts that were once just theoretical. And then, the rings. Yes, Neptune has rings. Most people don't even know this. First discovered in 1968 and confirmed in 1989 by Voyager 2, Neptune's rings have remained elusive ever since, until now. JWST has captured them with breathtaking clarity, showing full arcs, dust bands, and ringlets encircling the planet like a cosmic fingerprint. These aren't Saturn-style rings, but fragile and complex structures that tell a story of collisions, moon interactions, and ancient formation. With this imagery, scientists can now study their composition, structure, and evolution, potentially unlocking how planets like Neptune formed in the early solar system. But while Neptune stole the headlines, Pluto is still holding its own in this space race of discovery. The New Horizons flyby in 2015 gave us our first real look at Pluto. That mission unveiled towering mountains of water ice, massive glacial plains of frozen nitrogen, and a mysterious beating heart, Sputnik Planitia. But JWST has now gone a step further. With infrared precision, it's peeled back the hazy curtain of Pluto's atmosphere, revealing sharper contrasts in its surface composition, new textures, and temperature gradients that hint at something even deeper beneath the crust. Some scientists now believe Pluto may hide a subsurface ocean, a layer of liquid water buried beneath layers of rock and ice, kept warm by radioactive decay and internal heat. If true, this tiny dwarf planet, once mocked and demoted, could potentially harbor the basic ingredients for life. Add to that the discovery of massive bladed terrain, made entirely of methane ice, sculpted by shifting climates, and you begin to understand why Pluto is anything but dead. And remember that mysterious shift? Researchers think Pluto literally flipped on its axis in the distant past. A complete polar migration. That movement realigned its landscape, redistributing mass and terrain. This true polar wander has exposed older, unexplained regions of the planet, ancient, untouched surfaces that are like fossils frozen in time. It's as if Pluto is handing us a map of its entire geological evolution, if we can learn how to read it. So what does all this mean? It means we're just beginning to understand the outer solar system. These aren't static balls of rock and ice drifting through space. They're dynamic worlds, active, mysterious, possibly habitable in ways we never imagined. And with JWST's unmatched clarity, we're finally able to witness it all: glaciers moving across nitrogen plains, methane clouds drifting over ice giants, ancient oceans sealed beneath fractured crust. This is more than science. It's revelation, because in the silence of deep space, two frozen worlds are speaking. And for the first time, we're finally listening. So here's the question that's echoing across observatories and labs worldwide. If Pluto and Neptune are this dynamic, this alive, What else is lurking in the frozen outer reaches of our solar system? With the James Webb Space Telescope now opening its eyes wider than any telescope before it, the boundary between known and unknown is collapsing fast. And the discoveries? They're only just beginning. JWST was built to study the birth of stars and galaxies billions of light-years away, but it's proving to be a game-changer for the cold, dark frontiers of our own cosmic backyard. While its mission wasn't aimed at the dwarf planets or ice giants, what it's revealing about them is stunning. Through its infrared gaze, it's pulling back the curtain on entire worlds once considered static, barren, and forgotten. And in their place, it's showing planets that breathe, shift, and evolve. Take Pluto's fractured surface. Those jagged methane ice ridges, known as bladed terrain, weren't just random formations. They're climate scars, etched over eons by cycles of freezing and sublimation. These massive structures tower hundreds of feet high, shaped not by tectonics or volcanoes, but by Pluto's seasonal shifts. And here's the twist. Scientists believe similar bladed features could exist on other icy worlds, perhaps even the moons of Uranus or distant objects beyond the Kuiper belt. This is forcing planetary scientists to rethink what's possible on frozen celestial bodies. These are no longer just icy rocks. They're living laboratories, places where chemistry, climate, and geology intersect in ways we're only beginning to understand. The idea of oceans beneath crusts of ice on Pluto, on Europa, on Enceladus is no longer just a theory. It's a model we're refining with every new spectral readout from JWST. And each reading tells us the same thing. These places aren't dead. They're dormant. Meanwhile, Neptune, ghostly and majestic in JWST's recent images, is revealing atmospheric complexity like never before. The methane clouds, the polar vortices, the evolving weather bands that swirl across the planet's frigid skies. And then there's the magnetic field, tilted and offset in ways that still baffle scientists. JWST's ability to track high-altitude clouds and ring structure could help crack the mystery of Neptune's interior, something Voyager 2 only began to hint at. But there's another mystery unfolding, and it's one JWST may help solve soon. Planet 9. That's right. Some astronomers believe the strange gravitational behavior of certain distant Kuiper belt objects hints at an undiscovered giant planet, far beyond Neptune. A massive body, invisible to previous telescopes, but possibly detectable by JWST's deep sky scanning power. If Planet 9 exists, it could reshape everything we know about the solar system's architecture. And if it doesn't, well, then we've got even bigger questions about what's tugging on those orbits. Either way, we're entering a new era. An era where the outer solar system is no longer just background noise. It's the main stage, a place of storms, shifts, scars, and secrets. And we're watching it all unfold with precision humanity has never had before. Every signal from JWST isn't just data. It's a revelation. A reminder that in a solar system we thought we understood, there's still wonder, there's still mystery, and there's still a frontier. From the icy plains of Pluto to the ghost clouds of Neptune, the edge of the solar system is alive. And with JWST as our eyes in the dark, we're finally seeing the cosmos not just as it is, but as it's always been. Vast, violent, beautiful, and full of surprises.